example ago. So again, without using technology, sketch the graph of y equals 10 to x. So something like this you could definitely be asked in the non-calculator section. Okay, first I'm not going to explain in detail how to draw the tan theta function. Hopefully you have listened to the previous example and lots of videos for you to be able to know. Just realizing that I need to draw minus pi to pi, so that's why I drew mine like this, kind of in the middle. I always like to do pi over 2, pi, 3 pi over 2, 2 pi. Oh, I don't really need that much, I only need up to pi. But anyway, I've got negative pi over 2, and then pi, negative pi. Let me rewrite this because it looks very messy. Negative pi over 2. Okay, so we're really only looking at that window, so let's give it a go. My tan x has my sine function, so my sine x is 0 when x is, what were the answers? Pi and 2 pi. So they're my zeros. And then here as well. And then my cos x is 0 when x is pi over 2, 3 pi over 2, etc. So those are my asymptotes. So pi over 2 and minus pi over 2. Alright, so this is my original function. Let me give it a draw for you. Use this one, so it looks something like this. Using my negative pi, we should have a dot as well. So it looks something like this. There we go. So that's what my graph looks like. And then what I should have is tan 2x. So let me write y equals tan x. My y equals tan 2x have to be manipulated a little bit. Let's see what the notes say. So if b is inside and it's greater than 0, it has a scale factor of 1 over b. The graph has a period pi over b, horizontal dilation. So those are the notes that I want to use. I'll do it quickly because I'm running out of charge. Horizontal dilation, period is pi over 2 now, and then the scale factor is 1 over 2. So it's going to reduce by half, and my pi over 2 is my period. So at the moment, my period is pi over 2 to pi over 2, so it's a whole pi, but it's going to reduce, so there's going to be more oscillations. So let's give it a go. Everything is going to basically reduce by pi over 2. So my original function is going to be the same, but my asymptote is going to reduce. So maybe I'll use a black dotted line. So it's pi over 2 at the moment. If I do pi over 2, so asymptote divide 2 is going to be pi over 4. My other one's going to be minus pi over 2 divide 2, so it's going to be minus pi over 4, etc. So these are where my new asymptotes are. And that means that every pi over 4, there's going to be an asymptote, because that's how it works. So there's another asymptote, and there's another asymptote here. Okay, that graph is looking a bit messy, but we'll keep going. We'll do the x-intercepts. So my current x-intercept is 0, which will stay. Pi divided by 2, so that'll be pi over 2. And then minus pi divided by 2 will be minus pi over 2, and then we'll extend it further as well. I might use, I'll just use black dots to show that. So pi over 2 is over here, minus pi over 2 is over here, and then obviously the other dots will come in more that way as well, and that one stays. So let me see if I can use a different color, maybe green, light green, to show that. So this is what my graph would look like now. It stays in between those windows. As you can see, my period halved, so we are seeing more oscillations. So it's something like that. And then that one looks like this. And there we go. So there we go. Y equals 10 to x. Done.